Hey guys, it's Chris Pate from Cheat the Game coming back at you today. I'm taking a look at one of my partner's videos that he made. It goes by FlufferNutter. He is one of my go-to guys. He is extremely proficient in C# programming, so I go to him based on any questions I have about Unity games, Flash games, using things like JPEG software, dnSpy, and there's other software, but anything C# related, I mean, he is truly a master of. One of my go-to people for that. He's actually come out with a vid that he wants posted on the CTG YouTube page. Said that all the CTG members can watch it, learn from it. It's great stuff. It's called Breaking an Encrypted String for Unity games and C# based programs. He's going to be using a specific software that he's going to break the encrypted string to get the coding out from it, to see all the goodies we can find in it and everything. And he is really good. He goes over it really carefully to make sure that you understand, but this is a more intermediate to advanced lesson, so beginners, you can pick things here and there out of it, but it is good for all of you to watch it. And this is some must-know information, because this can branch off into other avenues of game hacking and coding and tracing and anything you can think of in that matter. So it's always good to see someone else's style and how they approach things. I want you to see it from a C# programmer directly. I also want to acknowledge my partners right quick, all of them. These guys keep Cheat the Game going. If it weren't for these guys, I would have to shut it down a long time ago. So I really appreciate your indulgence with this intro. Without further ado, I bring you my pal FlufferNutter and his tutorial on breaking an encrypted string for Unity games.
Today we're going to be looking into C#, the programming language, and why it is such a horrible language to be doing games or programs or pretty much anything in if you're not doing it open sourced and if you want to actually protect anything. We are going to be looking at this program, MegaTrainer. I forget who it's by. Maybe it's by MegaTrainer. I don't remember. But when they send over the game hack information, it's all encrypted. So we're going to look how to decrypt that string so we can see what codes are being passed back and forth. This is going to work the exact same for Unity games because they're all built with C# as the baseline code. So we're going to open that up, let it load up real quick, and then we're going to look at Charles so we can see what information is being passed back and forth. So here we go. So we don't need any of this yet. We'll look at this, and right when we load up a game, it's going to pull all the information through. So we'll look over here, and it's going to be by the version ID. And here's your little encrypted string. So I'm not going to go into too much detail of how C# works or anything like that. I'm just going to show you the basic techniques of how you can use C#, even if it is encrypted, because this will be encrypted when we do this, how to break into it and how to use their own encryption to decompile their string. So first thing we're going to do is we're going to look into dnSpy, which if you do anything with C#, Unity games, stuff like that, you're probably familiar with this. And we're going to toss this program in there. If it opens. There it goes. Now when you first open it, it's going to look like it's actually unprotected, but it's not. I forget what it's using. It's easy something as an encryption string. I probably spent maybe like an hour and a half going through each one of these classes until I finally found something that was somewhat useful. But since we do know with Charles, since the information is coming in through an XML and it's reading from a web server, that's kind of like the key points that we're going to be looking as we're going through. So the first one that we're going to look for is an HTTP request. Here we go. We have an HTTP client. So this would be one thing. You'd look through it and see what you're doing, and you can already see that it's starting to talk about XML, and it's getting the information from that. The one thing that's nice about C#, even with it being encrypted, is you can run the program from dnSpy. If they have an anti-debugger on there, then it makes it a little bit harder. But at the moment, when we decompile this so we can read this a little bit better, you can't run the program. So at least at the moment, it's still a little bit encrypted. All this stuff, you can click through to it and see exactly what it's doing. But since it's still encrypted with its encryption, we can just start the program. We don't need a break because it requires admin. All right, so we're on 200B. All right, I put us right back where we were. And don't break. So when we start this, like I said, even though it is encrypted, the program should still run perfectly fine, and we could add breakpoints all over the place. So we could see when and where the information is passing through and figure out the encryption that it's using. So here it is, loads up perfectly fine, and it's going to work. So since we know that we're working with an XML file that's coming through that's going to hold the codes, we're just going to breakpoint everything to figure out where it is. So even though the program's running, you can still start adding them right now. This one, don't see any. Don't see any. Here's another one. Hey. I think I just added an entire class breakpoint. Maybe not. We'll see. Here's another one. That's a result. Yeah, we'll see. There's another one. There's another one. Alright, so let's run it as that and see what happens. See when it's going to start breaking down on us. Alright, so we've already got one. Now, this is the very beginning start of the program, and we did not see that file come through until we clicked on a game. So we know that that one's going to be garbage. So we're not going to need that one. Same thing, that we have not clicked on a game yet, so that one's not going to be working. And we're going to continue this until the program loads. Nope. So most of that just could be pulling through all this information. Alright, so now we're going to click on games, and it should break somewhere. Okay, it didn't, so we'll keep scrolling down. So at least, obviously there was more. That one hasn't hit yet. Hasn't hit. Here's another one. No XML. There's another one. And a lot of this is going to be trial and error because we can't see their original source. But we're still going to use their own information against them, because they don't have just a regular encryption string going through it. When I did this the first time, they're actually using a byte conversion. Alright, so let's do a different one. Alright, so now we actually have a string that popped up. Let's see, so it's going to be string, but that's 08. So we're going to run right through this. You can step into, and it's going to go through the entire code as it moves, but we just want to step over because we want to see what this string is going to turn into. And this looks... Gold, silver. Okay, so this one's just trying to figure out if you're a paid member or not. So I'm going to go with, we'll skip over it one more time, see if anything else comes up. No, it's still talking about paid members and stuff. So I'm going to say that one's not important. I'm going to see what the string comes into here. Okay, so now we actually have a cheat ID. Frozen, hidden, pointer address. Okay, so now we're actually getting information. So this is the one that we're going to want to be looking at. So it'll be line 581. And we're looking in view. Now, when we finally decrypt this so we can read it a little bit more, these will change and they will not be in order. So it's going to be kind of just surfing through till we find it again. But like I said, if you decrypt it first, you're not going to be able to run the program and put any breakpoints. We are going to stop the program here though and turn off any other breakpoints if there are any. Alright, so now we know which one it's going to be. We can follow it through real quick to see exactly what it's doing. And yeah, so this is going to be their actual decryption section. And right now it looks like garbage. You cannot just take this, copy and paste it, and throw it into Visual Studios, and it will not work. So we are going to have to decrypt this real quick. But this is going to be their class file that's taking that string and converting it back over into something readable. Now, at this point in time, you could just call it done because we've already grabbed their information. You could just dump it like that, but this is a lot of work. Having to go through every single game, wait until it goes through. So we're going to kind of show how you could take their information and just dupe it real quick. So now that we, so we want to, real quick, just so we have some information as we go. So this is the encrypted version. So now we need to dump the file. So we can throw it back in here and look for the unencrypted. So that we're going to use D for dot. It usually picks up everything. It doesn't work with some of the newer stuff, but the protection that they're using is a little bit outdated. So if we just throw it into there, it'll go through. I did get this error about the not renaming it. I didn't see an issue because neither way, even if you don't rename it, even if you do, it still will not run in debug mode. So you don't have to do any of that because we're not looking to run this. We're just looking to view it. And of course, I can't just drag and drop stuff in here. So open desktop cleaned. Alright, so we're going to look in the same section, but now all the names have been changed, everything else like that, so we cannot just base it off of this U number. So we're going to do the same thing, we're just going to scroll through, but now we know for a fact that there was actually crypto in there. So that's going to be the thing that we're looking for. And one of the cryptos starts with an R, I forget what the name is. Do, 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 do. Oh, nope. Nope. This is the fun part, just looking at random stuff. Ooh, there we go. All right, so we found the class. So, if I could spell Visual Studios. We're going to make a brand new project, and we're going to import their class straight into it. Windows format, doesn't matter the name. I don't want to step you through how to use Visual Studios either. If you're thinking about getting into C#, Unity, stuff like that, most of the stuff you should already know, at least a little bit about. Copy and paste it straight through. No errors, no nothing. And it should build perfectly fine. Yep. No errors, no nothing. So the program builds. So we're going to use this. So we're going to go straight over to, let's just make a button real quick. And we're going to put it all in a, we're just going to console write it. Alright, so we're going to be using this class that we just took straight from their program. We're not going to modify anything. We're just going to use it. It's called G-Class8. Don't need the designer no more. G-Class8 dot, we need to declare it as a class. Call it G-Class equals new G-Class8. Now we can use the functions inside of it. So if we do G-Class8, now we can have all this. So let's go back over to dnSpy. We're going to figure out exactly what it's using when it first enters it. And here's the notes, why we keep them. So this one was 200B. Right here. We'll scroll down to, oh, there's breakpoints. These never actually worked. They never did anything. So we can remove those. That one never did anything. Was this the right one? Yep. So this was the right one. So when it's when it's doing it, it's calling G-Class8 and U008. But since we decrypt it, it's gonna be called. It's gonna have a different string name for it. But we know that it starts out with building a string. So if we run over to the class real quick. Here we go. So it's going to be method 2. Method 2. And then we're going to input a string. We're going to grab the one from Charles. So let's open up the program again. It loads so slow and I don't know why. Unless I didn't open it. Let's try again. Oh, okay. Sometimes opening things helps. Alright, so start without an account. We're going to clean up Charles a little bit so we see what we're doing. Click on games. It's going to load. Once it loads through, by version, the response is what it sent us. So here's our string that we're going to want to use. So let's stop that for a moment. We'll leave that open. Alright, so there's our string. And we're going to pass the information over encoded. We are going to set a breakpoint on this in our program. We're going to write to the console. The information that passes back. Let's not breakpoint it, let's just run it. But we do have an error. So it's not going through the whole thing. We're going to see where it breaks at then. This is the one that we want to add a breakpoint to. We're going to start it up, click the button, and then these have the same controls as dnSpy. So we're just going to walk through it real quick. And we are going to look at our locals as we do it to make sure that everything is populating correctly. So string 0 is still nothing at the moment. Just going to push it through in a minute. And invalid length for base 64 character string. Invalid length. Pushing an array. Alright, so we have the class that they're using, but we're not sure exactly how they're decrypting it and what the full process is that's going through. So we're going to close this real quick. We will not need Charles again. Make sure that I did copy that correctly. 1B. Oh, it'd be nice if I put an N on there. Alright, what about now? Oh, okay. Alright, so I just forgot the beginning N. Taking it to the bytes. Creating the decryptor memory stream. Okay, but we have an issue. Okay, string is null. Does it ever build string? Should have right here. String 0. Oh, we got a null byte though. Byte 1. There's an underscore. Where does byte 1 come in though? Private byte. Password. So string 0, byte 2. So we have byte 2. What is string 0? So let's figure out what uses this method in here. And nothing. Okay, so we do not know what's happening in this. So this must be failing because it's not giving us our second byte for decryption. So we can just go straight over to dnSpy. we will go into here, and instead of just looking at this section right here, let's scroll up, and I want to know what this U is. So insert breakpoint. Let's start it. We're going to wait patiently for this slow program to load. There we go. Alright, so there we have a password. So U equals this. Let's copy that. Where was that at? So we're just going to do, we're going to take the name straight from here. It should be passing something else through, but we're not even going to do it. We're just going to pass it straight away. And this actually happened. This was the program's not even fully open yet, so let's pass it right away over here. Let's stop this. So we're going to do string password. We're going to pass it that. That's awesome. I just want this. Copy. Alright. Let's do it manually then. Is there spaces? No, there's no spaces. And so we need to pass that there first, since that password section came up beforehand, so we don't need to write it this time. We could just do G-class 8, and that was method 0. Yes. So this is going to build our byte 1, the one that came up null. We need to build that first. Method 0, and we're going to pass a password. Alright, so now make sure it all looks right. Alright, so we're going to populate that byte 1 first, because that's the one that failed on us. It came up null when we ran it. So let's start it again. Click our little button. Okay, so we're going to step into it. It's going to do the same thing. Now we know where we lost it at. It lost it right here. So we're going to skip over all this real quick. Alright, so now let's start from here. So this byte 1 actually has some information now. So there we go. So we're going to step into doing the memory stream again. And we still get an issue. System random. Alright, so where are we losing this at? Alright, byte 2, 73. 73, so we know that one. Let's see. Now we can compare this off against the real program. So let's make sure that the byte array is pushing properly. So that would be should be about the same. So it should be, oh, is it the read only or the private byte? Byte 1 is just the private byte, not the read only. Alright, so it's 205. 205 is what we want to find out. So we'll step into it and let it build that. No, it won't be there yet. Step over. So this 2005. So this is the one that we want to know now. So right after we step over this information should populate. Alright, so we've got 53 DA. Let's use some calculus. Hey now. Calculator. So 53 is 83, so that's right. It's 32 for the length. This is 20, which is 32, and it ends with 38, which, oops. Last one is 26, which is 38. Alright, so that's not giving us our issue. So what is the... So we're just going to get off this real quick. Yep. We're going to step through the encryption in dnSpy and figure out what information is not being passed over yet. Because padding is invalid. Alright. Here's a program. We'll load up a game. That's where it's going to break us at, so we're going to step right into it. It's not that one. It's not that one. Alright, here we go. So this is the string that it's going to give us. Let's see that real quick. Unless I just copied it incorrectly from Charles. And it's got a whole bunch of dots after it, so it's not even going to show us the whole string. That's nice. Alright, so we'll put that back to what it was. And we will continue. Alright. So we're going to keep stepping into it. Yep, logged in as a guest, don't care. Alright, so that's converting it from base 64 from the original string. So this part doesn't matter, we can step over it because this is just the background decryption. That's stock. So let's skip over that completely. Alright, so byte array 1, which will be array 2. Start this button, step into it. Alright, so this underscore byte is 32 long, starts with 101, and the close calculator. 101 equals 65. Oh wait, oh no, yeah, array 2 should only be 10 long. So let's see. In hex, 10 is 16, not 32. But for some reason, byte 0 is coming up with 32 long. So here's our first little issue. Let's figure out what's going on. So we're doing 16. $17 byte array. So it's taking this array, so we can't just copy and paste that number in there then, because it is, wait, actually, strings, yeah, because it is pulling from the string that it's giving us. So let's see. Why is this one coming up as 32 and not 16? So let's stop this real quick. Oh. Or I was on the wrong string number. Let's try this one. Then I could look really stupid if I grab the wrong XML file. So it'd be this one. That does not start with a C. It starts with an F. Lowercase. Start. Button. Step into it. Okay, so we can step over this stuff. I want to know what this byte now is. Still 32 though. Well, let's just keep going. And it's still going to give us an error. So request, but we want the response. And this one doesn't have anything, right? Cheat count, cheat by version ID, cheat. Okay. Alright, so let's look again. So we might be pulling the string from the wrong location. So we're going to close that real quick. Since we have this running still, we'll just continue. Let the dnSpy catch back up. And we're going to see exactly where it's coming from. Alright, so we're going to start Charles again. We're going to pick a different game. Here we go. And then we need to figure out okay, this one's not needed. 428. No, we're at 581. Okay, so this is the one. So if we step over real quick. Oh no, I wasn't supposed to step over. So we'll just continue. We'll load this one back up. We're going to step into. So FT. So it is the cheat one. So let's try this real quick. We can stop that. Go back over to form. We'll just run it. And still the same issue. Still 32 bytes. and that is byte 0. Alright, let's see if it's doing anything else before it runs through. So we're going to go back a page. What is this? No, that should be garbage. Alright, so it's taking the string and it's pushing it straight through. So it's not doing anything else before. Looks like a normal base 64. So we can skip over that. Skip, skip, skip. So it's still the same. Yeah, we're not going to do that. So FTNP. Oops. FTNP. Alright, so absolutely nothing's changed yet. So it would be array. So step through. Step through. Still the same thing. So let's run this real quick. And I want to see if it's doing the same thing. So step into. String. Oh, why is string 0 coming up with nothing? Alright, let's make sure that that's doing something. Output. Huh. So it is not passing the string through? Which doesn't make sense. Alright, let's unseal this. Maybe that's our issue. Locals. Still nothing for string. So public. Public, public. We were able to pass this one through. Method 2 passes string. Method 2 passes string. I didn't spell it wrong. Alright, so what if we just cheat real quick then? See if this works. So this will be string 0. Alright, let's try this. Okay, so we got the password. String. Oh, it might be because it's too long. Yeah, that's what the issue is. Alright, so it is pushing the string through properly. It's just the string was too long to display the characters. Alright, so now we're back to figuring out why this first array is coming up incorrectly. So it's from base 64, convert string 0. And we want the first array. We'll look at it this time. So it's, yeah, the array is huge. This one is. Alright, so let's continue, start. Well, that one's right. So let's see. Where's dnSpy? 15. Fifteen's 21. Okay, so it's pushing it now. Weird. Or is it just not setting it as array? This byte 0. Okay, so back to that. Where is, there it is. Array. Oh, because I'm looking at byte 0, not array. Alright, so what is byte 0? Byte 0. Byte 0 is being populated here. Byte 0 equals password. Okay, so that's being populated, so that one doesn't matter. So where are we at? We don't need that. We don't need that. It's method 2. I saw another one with string. Let's push it to method 4. Oh, there we go. Okay, so why is there 2 methods then? So method 2, base 64, 16, 16, base 64, 16, 16. This method 8. Huh. Let's go back over here then. See where we went wrong. So we're saying 008 when we click on it. Oh yeah, that was my bad. I just saw that the string at string. I didn't look for the right one. I don't see a difference in them though. U006 gets string. Array 3, array 2. Array convert from base string. Convert from base string. Array take skip. Huh. I do not see a difference in them though. Interesting. Alright, so we were just pushing to the wrong part of that class. Let's close this real quick. I can't because it is running in dnSpy, so we're going to stop dnSpy. Alright, so, but we can see that we did get the information to pop out. And it kind of looks like cheat engine tables, which is kind of cool. So let's clean this up a little bit. We don't need that. We figured out that this was, yep, let's stop the program, huh? All right. All right, so, and we're going to make this one private. Private versus public is private. We can't use it anymore. So if it's method 2, we try to do like G class 8, and then method 2 is no longer in there. That way it doesn't accidentally screw up and use the wrong one again. Passwords should be the same because this looks like my hardware information. And then just encoded is going to change. So let's make a designer real quick. Insert rich text box. Stupid auto size. It's weird. I do not see auto size. Alright, let's use rich text box. I think we could write stuff in there, right? Yeah. I also don't know why it doesn't dock on this computer. Well, it kind of does. I don't know. Alright, so we're going to use this to put the code in. So encoded equals, instead of this, we're going to do rich textbox1.text. And then instead of doing this, we're going to do rich textbox1.text equals this. Okay. We're going to run it through, see if it works, so we can start this. Okay. Actually, there should be a different string right here, right? Yeah. Go to the end. Copy that through. Paste that in there. Decode. All right. There we go. So, why does this not look like it is full information though? Oh no, it is. Why does it not look like there's a code in there? What if we do a different string? Does everything work on this now? Oh, it looks like it's just description. So, all right. So let's clear this up. Open them back up. It's garbage for now. We'll clear this. Okay, so clear this one more time. Click on a game, and we'll click a different random game this time. So this guy. All cheats work with a human player. Oh no, doesn't matter. So should be this one. It starts with an L, but there is a IQ before that. And that's a capital Q. Button 1. Alright. And yes, now it's pushing it out like it's the correct thing. So there you go. So instead of having to try to figure out their encryption and manually make it and redo everything, we just used it against them. Which is, it works the exact same way with Unity. So one of the games that I did, they didn't use this type of encryption. They had a different encryption, but it was the same process. I used their own encryption to decode their strings. And since you can set breakpoints, you can change everything on the fly, it makes it a lot easier. But the one thing, this is why I do not do anything unless it's open sourced, because it's just so easy to break into, and I like C# because it's fast to build stuff. But the one thing that you can do is with debuggers, or anti-tampers, anti-debuggers, stuff like that. That does help, but because of this guy right here, D4 dot, it kind of makes it harder because it's not always updated with the newest stuff. So like Smart Assembly, the newest one, still isn't fully cracked, but it still decrypts it pretty well to where it's readable. So if we tried to do this, so at the same time, so let's open up dnSpy again. So we know this is the class file, and this is all the gibberish and everything else. If we tried to just take this, make a new class file, and just paste it in, we're going to get nothing but errors, the entire right side. See, nothing but errors because it's got this backslash. Even if you went through and you took out the backslashes and everything and you tried to clean this up, it still would not work. So if you couldn't decrypt this, because this right here is the password that we need to have. Oh, this wasn't even the right class. I don't think. Oh no, this is B. So this is the one with the encryption. So even putting this in here, see, everything's red, nothing's going to go through, and this password that we need this information right here, is encrypted. It's a byte array string encryption, which was fixed when we used D4 dot, and it told us what that was supposed to be. So even without that information, it would make it a lot harder to figure out what this is. But this is still simple byte array decryption. So it can be done, but it's so much easier if you can at least decode it a little bit. But that's it. That is literally using their own information against them to figure out what strings are coming through. Because with a lot of the Unity games that we used to do is we didn't care what information came back. We just wanted to send the correct information out to them. So when you're dealing with a server, most of the time the server is going to accept anything as long as its checks have passed. So as long as we're sending them valid data, we could start updating the server for the game with whatever we want to tell it. We didn't care what it was telling us. We just were giving it false information. But as long as we encoded it correctly and did everything that it wanted us to do, then it had no problem accepting our information. But there you go. That is why I did not want to go over C# basics or anything else, because this is already way too long. But that is how you can steal someone else's full encryption to use it to decode strings that the server will send back to either a program or a game. And that is all. I'm going to go have a beer now.